Last video here for section 6, or unit 6, I guess, of the class. This one's going to be called molecular and polyatomic compounds. So these are the other types of compounds that we're going to learn how to name here in the first year chemistry course. All right, so type 3 compounds are compounds that we call covalent compounds. They do not contain metals at all. So everything that kind of houses inside of a covalent compound is located on the right side of the table. So if you look for carbon dioxide, carbon and oxygen are on the right, and NO2 and P2O5. Hydrogen is a very common element in a lot of covalent compounds. So what we're going to say is that hydrogen is a cation. If you see it as a cation, if you see it as the first thing, we're going to treat it as a metal. Otherwise, we are treating it as a nonmetal. So the C6H12O6 that you see there, we would call that thing covalently bonded, and we wouldn't name it using ionic naming rules. Okay? So the difference between these types of compounds and ionic compounds is that these compounds share electrons. And when they share electrons, instead of transferring them back and forth, one atom actually owns the electron a little bit more than the other one, but the one that does own it a bit more is still willing to kind of transfer it to the lesser atom. So there's a sharing of electrons back and forth. That's covalent bonding. Because they're sharing and not transferring, these types of compounds do not form ions. So if you were to take a covalent compound, like sugar for instance, and put it into water, no ions would form. And if you'd put a conductivity probe inside of that solution, there really wouldn't be any conductivity either. So this sharing leads to multiple types of compounds. Let me just look at nitrogen and oxygen, for instance. There are really 3 different types of nitrogen and oxygen compounds that can be created via this type of sharing. There's nitrogen monoxide, dinitrogen monoxide, nitrogen dioxide. There's a couple of more, but those are probably the 3 main ones. So what I'm trying to get at here is there's like no valence electron system that we can use to name these things. But if you heard me name the NO, N2O, and NO2, I was using things like prefixes to explain how many atoms were involved in each one of those compounds. So that's what we're going to do for covalent compounds. If you see a compound that does not contain a metal, you're going to use these things called prefixes to define the number of atoms involved in the compound. And here are the prefixes that we will use, starting with mono, which is the prefix for 1, and ending with deca, which is the prefix for 10. So let's do a couple examples before we continue. Let's start with just something common so you can see how this works. So you know this stuff, and you probably know the name of it. So the name of this stuff is actually called carbon dioxide. And it's not the only carbon-oxygen compound we know of. There's also this stuff. This is carbon monoxide. And I want you to notice something with both of these. In both of these compounds, there is only one carbon atom. But we do not use the prefix mono with carbon. That's because you never use the prefix mono with the first element in a covalent compound. We would never say monocarbon monoxide. It's just carbon monoxide. That's it. It helps us shorten things up. That's really the only reason. All right, so there's 2 you might be familiar with. Let's go the other way. Let's go with this guy. Chlorine disulfide. Okay. Now, when it's a covalent compound, there is no metal. We do not use the metallic naming rules. There's no crisscrossing. There's no ion finding. All we're doing is writing down the elements, which we know to be chlorine and sulfur, and then looking for prefixes. If it's disulfide, that means 2 sulfurs. It has nothing to do with charge. It just means that there are 2 sulfur atoms. So that would be our formula right there. One more. Let's go with dinitrogen tetroxide. Okay, again, let's write down the elements. We know it's nitrogen. We know it's oxygen. Dinitrogen, 2. Tetraoxide, 4. Now you might say, oh, Cornick, we got to reduce that. No, you don't. With covalent compounds, there is no reducing at all. You keep it the way that it is written, because covalent compounds, like the one you see right here, are the exact molecule. They are not crystal lattice structures. They are not empirical formulas. They are molecular formulas. So you never reduce when you have a type 3 compound. All right, now let's go to type 4 compounds, which are probably the most complicated. These are compounds that actually contain both ionic and covalent bonds. Here's an example, NaNO3. You'll notice that there's more than 2 elements in these types of compounds, in type 4 compounds. That is the single biggest giveaway that you have a type 4 compound. There are more than 2 elements. You have sodium, you have nitrogen, you have oxygen. So the bond between this sodium and this NO3 stuff, that's actually an ionic bond. The sodium has its traditional 1+ charge, and the NO3 thing has a 1 negative charge. That means that in order for the nitrogen to bond with 3 other oxygen atoms, it must go and find an electron. Well, it just happens to be that in this case, sodium has that extra electron to give away. So these two, the sodium and the NO3 stuff, are kind of a good match. They're a match made in heaven. Now the bonds within those parentheses, the bonds between the NO, are actually covalent. These types of ions have a special name. They're called polyatomic ions. Poly means many, atomic means atoms. So many atoms that come together to form an ion. Now you might say, we'll go back here, how do I know the names of these things? You know, like chlorine I know is chloride, and fluorine is fluoride. What is this? Is this nitrogen trioxide? That might make sense using the type 3 compound nomenclature that we used in the previous slide, but not quite. Anytime you see a polyatomic ion, you are going to refer to this handy dandy sheet that I'm going to give you in class tomorrow. You will have this sheet on any quiz. You will have this sheet on any test from here on out. This is the polyatomic ion sheet. It is a sheet that I will put on the other side of your periodic table. You're going to get a new periodic table / polyatomic ion sheet tomorrow. And this thing will go into your binder and get used a ton. So this NO3 thing, you know, if you want to know, well, what is NO3? You just got to go find it on here. It is right there. And its name is nitrate. So if you were going to go ahead and name the thing that I put up there, which was NaNO3, we would simply call that sodium nitrate. And I'm going to stop us there for right now. Only an 8-minute and 15-second video, and we'll talk more about this stuff tomorrow.